More and more children are out of school, but parents don't want math learning to stop. They're turning to Mathnasium at Home, real-time math instruction tailored to your child's exact educational needs. It's the same face-to-face live instruction used in our centers for over 15 years, now on a computer. Your child can keep their math skills sharp, catch up, or soar ahead, from home or anywhere with an internet connection. To learn if Mathnasium at Home is right for your child, visit mathnasium.com/at-home. Mathnasium at Home, changing lives through math.
Hello everyone, welcome to Mathnasium Schoolhouse. Today we are going to be doing the first video in our problem solving with fractions series. So while we wait for everyone to join, make sure that you have today's worksheet downloaded so that you can follow along with the problems that I'll be doing. And go ahead and let me know what your name is, where you're from, what grade you're in. Maybe if you go to Mathnasium, let us know that as well. And we will go ahead and get started. All right, so like I said, we're going to be doing problem solving with fractions. So in the first couple exercises, we want to restate the question that's given to us. Using the information, we can use some question marks for unknowns, and then we'll find the answer. So let's go ahead and read along on what this first problem is going to be. So a candy store sells mints, taffy, and caramel. If 5/8 of the candy in stock is mints and 3/16 of the candy is taffy, what part of the candy is caramel? So, like we said, we know that 5/8 are mints. Actually, let's write this a little bit differently. 5/8 are mints. 3/16 are taffy, and we're not sure what part is caramel. That's what we're looking for here. And we know that the number 1, the whole, represents all of the parts, all of the different types of candy that we have in stock. So we're looking for 5/8 plus 3/16 plus what equals 1. So when we're thinking about that with fractions, we know that we need a common denominator. So what can we do to have 5/8 have the same denominator as 3/16? We multiply the top and the bottom by 2. That gives us 10/16, which we know is equivalent to 5/8. And now we can figure out what part is missing. So together with my mints and my taffy, I have 13/16. So I know that the piece that I'm missing for caramel is 3/16. And the next thing we need to figure out is if that's in lowest terms, which it is because 3 is a prime number. So 3/16 of the candy in stock is caramel. Nice job. All right, let's do a couple more of these. 1 pint is 1/8 of a gallon. What part of a gallon is 3 pints? So step 1, our related question, we know that 3 pints is 1/8 of a gallon how many times? 3 pints is 1/8 of a gallon how many times? Three times. 3 times, very good. Oops. 3 times, so 1/8. 3 times, well, 3 1/8 gives us 3/8. And that's in lowest terms, so 3 pints is 3/8 of a gallon. All right, number 3. 1/5 of a chocolate chip cookie has 30 calories. How many calories are in a whole cookie? Well, we know that the part is 1/5. The whole, we're asking how many calories are in the whole cookie. We don't know that yet. We're not quite sure of that part yet. So there are how many calories in a whole cookie? Well, if each fifth is 30 calories, I know I have 5/5 in a whole. So what's 30 5 times? Very good. 150. Well done. Very nice job. Okay. 1/5 of a piece of candy costs $1.50. How much does a whole pound of candy cost? 1/5 of a pound of candy. What part? 1/5. And we're looking for the whole. So we're not quite sure what the whole is yet. So how do we go about this one? Yeah, very good. $1.50 5 times. We know that $1 5 times is $5, and 50 cents 5 times is $2.50. And if I add that up, I get $7.50. Nice job. All right. So if a cup is 1/16 of a gallon, what part of a gallon is 10 cups? 1/16 of something equals 10. Oh, I'm sorry. We're looking at 1/16. How many times? 10 times. 1/16 10 times gives us what? Gives us 10/16. 1/16 10 times is 10/16, which we can reduce to 5/8. So if a cup is 1/16 of a gallon, 10 cups is 5/8 of a gallon. Nice job. All right. How many months are there in 5/6 of the year? How many months are there in 5/6 of the year? We know there's 12 months in a year, so if we're looking at 5/6, can we get this fraction to have a denominator of 12? If I multiply both by 2, I have 10 twelfths. And again, there's 12 months in the year, so if my numerator is 10, I now know that 10 months is 5/6 of the year. All right, a little bit longer problem here for number 4. A florist sells a bunch of different flowers: roses, violets, and tulips. If 7/20 of the flowers in her store are roses and 8/15 of the flowers are violets, what part of the total number of flowers in her store are tulips? So I've got 7/20, I've got 8/15, I've got some unknown number to get to my whole, to get to my total, right? So how can we go about this? We need a common denominator between my 20ths and my 15ths. So does anybody know what our common denominator would be? If I multiply both by 2, or if I multiply 20 by 2, I get to 40. And 15, there's no way to multiply 15 by anything to get to 40. What do you think? 60? I can do 20 times 3, and that gives me 21. If I do 15 times 4, that gets me my new common denominators. Still have plus my question mark to get to my whole of 1. So what are we working with now? Well, I know that my roses and my violets are 53/60ths. So what do I need to get to a whole? Very good. 7/60ths. Well done. Can we reduce that at all? Can we reduce 7/60ths at all? No, correct, because 7 is a prime number. Nice job. All right. 2/7, the height of a sailboat's tallest mast is 8 feet. 2/7, the height of a sailboat's tallest mast is 8 feet. So we have our part. We have our 2/7 of some number equals 8. Two sevenths of some number equals 8. I see the answer in there a couple times. Nice job. Nice job. So if 2/7 is 8, 2/7 of our number, of our unknown height is 8, that means that 1/7 is 4. And if 1/7 is 4, what would 7/7 be? 7 times 4 is what? 28. Nice job. 28 feet. Okay. So what can be helpful with these is drawing a picture. Sometimes it's helpful to draw a picture in order to get to our solution for our fraction problem solving a little bit better. So if we're looking at this example here, Papa Bear ate a quarter of a pie, Mama Bear ate 2/3 of what was left. What fractional part of the pie was left after Mama Bear finished? All right, so in our picture here, we know that Papa Bear ate a quarter of the pie, so he ate 1/4. And Mama Bear ate 2/3 of what were left. So there's only 3 parts left, right? We have 1, 2, 3 parts left, and she ate 2 of them. How much of our pie is left? Out of the whole, we have 1/4 of the pie left. We have 1 of our 4 pieces remaining. So we're going to go ahead and try that here. So if a fish tank is 3/4 full and 1/3 of the water leaks out, how full will the tank be? So first of all, it's 3/4 of the way full. So we need 1, 2, 3. So our fish tank is 3/4 of the way full. And 1/3 leaks out. 1/3 of my water leaks out. How full is the tank now? Yeah, exactly. 2/4, which we could also reduce to 1/2. Our tank is half full now. Okay. So when it's a quarter of the way through the first half of a soccer game, what fractional part of the soccer match is left? So we have our first half, and if it's a quarter of the way through the first half, so that means just our first piece here needs to be divided into quarters. So I've got 1, 2, 3, 4 parts in my first quarter, and those are not very even. Let's try that again. That looks better. And if my first half is divided into quarters, and it's one quarter of the way through the first half, this is all of the match that's been done. So out of the whole, what part of this fraction would we say that that is? Well, if my first half is divided into quarters, my second half can be as well. So now looking at this, how much of my total match is completed? I've completed 1/8, which means how much is left? Well, if I've done 1/8 of my match, of my soccer match, I've got 7/8 remaining. All right. Do a little bit more with pictures here. A bowl was filled up 4/5 of the way with dog food for Fido's dinner. He only ate 3/4 of the dog food in the bowl and left the rest. So how full was the bowl after Fido finished eating his dinner? So he ate 3/4 of his food, but it started off being full 4/5. So we can see there we have 4/5 of the bowl filled up, and he ate 3/4 of the food that was there. So we can see that only 4 of our fifths are filled up, and he ate 3 of our 4 parts that are available. So how much food was left in the bowl? How many squares, how many rectangles do we have remaining that are filled in? We have 1 out of our total 5 that were available. All right. So if there were 4 ounces of food left in the bowl after Fido finishes dinner, how many ounces of Fido's food does his bowl normally hold when it's full? So if 1/5 of his food was left, of the total, of some amount was left, and that was 4 ounces, how much does his bowl normally hold? We can go back to our picture and we can count, or we can think in wholes and parts. And if we know that 1/5 is 4 ounces, 5 times to get to our whole of 5/5 would be 20 ounces. Okay. So for this one, we have to draw our own picture. So Jessica saved money to buy holiday gifts for her family. She started her holiday shopping by spending 2/7 of the money on flowers for her mother. She spent 3/5 of the remaining money on chocolates for her father. She used the rest of the money to buy a bracelet for her sister. So Jessica started off by spending 2/7 of her money on flowers for her mother. So we are going to start off by drawing our picture here. And we know that we need it in 7ths. We didn't quite get enough there. We'll just tack one more on the bottom. There we go. So now we have our 7ths. And we know that she spent 2/7 on flowers. So our first 2/7 are spent. She spent 3/5 of the remaining money on chocolates for her dad. So we have 5/5 remaining. She spent 3 of them. So that's the money she spent on her dad. And she used the rest of the money on a bracelet for her sister. So our last 2 parts of the picture there were spent on that bracelet for her sister. So what fractional part of the money did Jessica spend on her father's gift? Well, that was the second part, and we can see we have 3 pieces colored in out of our total 7. So we could say that she spent 3/7 of her money on her father's gift. And if she spent $12 on her sister's bracelet, how much money did she have saved altogether? Well, we know that she spent how much on her sister's bracelet. We can see in our picture. She spent 2/7 out of her total amount of money on her sister's bracelet, and that was $12. So if 2/7 is $12, then 1/7 of something is $6. Very good. She had saved up $42 altogether. All 7 of our 7ths up here was $42. Nicely done. All right, using our picture here. Howard is playing in a high school basketball game that is halfway through the 3rd quarter. What fractional part of the game is left? So we've done our whole 1st quarter, our whole 2nd quarter, so we're halfway through our game, and then we're only halfway through the 3rd quarter. We're halfway through our 3rd quarter. So if each quarter was divided in halves, how much of the game is left? I can see I have 3 parts left, and what's my whole now? Very good. 3/8 of the game is left. Halfway through the 3rd quarter is 5/8 of our way through the game, which means we have 3/8 remaining. So if there are 12 minutes of playing time left in the game, how many minutes was the entire game? So if our remaining piece here is 12 minutes, how much time was the whole game? If 3/8 is 12 minutes, then 1/8, one of our 8s, must have been 4 minutes. And if 1/8 is 4 minutes, 8/8, 8 4 times is 32 minutes. Okay, very good. So we're going to draw a picture for this next one. When Andrew got into his car to drive home from work, he saw that his fuel gauge indicated that his tank was half full. And when he pulled into his driveway, the fuel gauge showed that he had used 1/3 of the fuel that was in the tank before he started his trip home. So if we have our fuel tank here, and when he got into his car to head home, it was half full. So if he used a third of the fuel that was in his tank, he used a third of the fuel that was in his tank. So he used this much. He already was empty a half. And he used a third of the half that was left. How much fuel was in the tank when he got home? We took our first half, and we use a different color here. We took our first half and we divide it into thirds. So then our whole piece was divided into sixths. And if I have 2 of those remaining, I have 2/6 remaining, we can reduce that to what? 1/3. So his tank was 1/3 full when he arrived home. And if the tank had 4 gallons left, how much fuel can this whole tank hold? We said that it was 1/3 full when he got home, and that was 4 gallons. So if each third is 4, my whole tank can hold 12 gallons. Nice job. So if Kira is cleaning the tiles inside her pool, and the pool is 4/7 full of water at the start of the day, she decided to drain half of it before she started cleaning. How full was the pool after she drained out half of the water? So we'll get our pool going here and make that a little bit bigger. She said it was 4/7 full. So there's our sevenths. It was 4/7 full. 1, 2, 3, 4. Okay? She drained out half of that water. She drained out half of the water. So, oops. Half of those are gone now. There we go. All right. So how full was the pool after she drained it? What do we have left? We have 2. And what's our whole? 7ths. Okay. So if there's 1,000 gallons of water left in the pool, how much did she drain out? If there was 1,000 gallons left in the pool, how much did she drain out? Let's think about this. If these 2 remaining pieces are 1,000 gallons, and we know that she drained half of it, if we're talking about half being 2 parts the same, then if 1,000 is left, she must have drained 1,000 before she started cleaning. So how many total gallons can the pool hold? We'll go back to knowing that if 2/7 is 1,000 gallons, then 1/7 must be 500 gallons. So each of these sevenths is 500 gallons. So how much can the whole pool hold? Well, we've got 500, 1,000, 1,500, 2,000, 2,500, 3,000, 3,500 gallons. Our whole pool can hold 3,500 gallons of water. Okay. Last page here, and then we'll go ahead and wrap it up for today and get ready for tomorrow. So let's get these last few problems done. So Jackson's attending a lacrosse game that's halfway through the first quarter. What fractional part of the game is left? So our game here is split into quarters, and the game that he's at is only halfway through the first quarter. So if we take each of our quarters then and divide them in half, how many total pieces do we have? We had 8 total parts of the game, and there are 7 remaining. Nice job. All right. If there's 7.5 minutes of playing time, if 7.5 minutes of playing time have passed, how many total minutes of playing are there in the game? So if each of our 8s are 7.5 minutes, we can either count by 7.5s, or we can be a little bit smarter about it. And if I know that 7.5 and 7.5 make what? 15. So that means 2/8 is 15, or 1/4 of the game is 15. And I have how many quarters total? I have 4 quarters. 15 4 times is 60 minutes. So our whole game is 60 minutes. Nice job. So how many minutes are left? If I know the whole game is 60 and 7.5 minutes have passed, I know I have 52.5 minutes left. All right. Well, thank you guys for joining me today. I had a great time talking with you about fraction problem solving. We're going to do another lesson tomorrow about problem solving with fractions. So go ahead and tune in. Let us know if you enjoyed today's lesson. Share it if you did. For tomorrow, same thing. We'll have a worksheet to go along with it. So keep an eye out for that before the lesson starts. Try and have that downloaded and ready to go. And we will go ahead and call it for today. Thank you so much. And like I said, we'll see you tomorrow for part 2 of our problem solving with fractions series.
It's afternoons that seem to be the most hectic for us, so it was much more convenient when we found Mathnasium at home.
All right, so how do we do half of 5? I think one of the best things about at home is that it really feels like you're almost at home with the student in their house teaching them.
I'm in my comfort zone.
You can just ask for help and the instructor will come right to you.
With Mathnasium at home, I know that they're getting the help that they need.
Awesome, great job.
Mathnasium, changing lives through math.